Lab 7 is about continuous integration. We're nearing the end, right? So now we're going to add continuous linting and testing of the code. Next up, we're going to deploy it. Then we're going to be done with the labs. There's an optional lab 9. You're welcome to do it. Lab 7 goals. We're going to add linting to our code base. We're going to set up continuous integration using, in our case, Circle CI. And the first thing to do is open up the README. So can you guys actually see this? I don't know if I can make it bigger. That might mess up Alan's thing. I will then work in here. So FSDL text recognizer project. Lost my GPU while lecturing. So did anyone run stuff overnight, by the way? Some people?
Yeah, let's look at the leaderboard.
Let's look at the leaderboard. You'll notice I have dark mode, weights and biases. Ask Chris how to do that. So this is the FSDL text recognizer November 2019 project. And we have a bunch of runs. I guess what I want to see is, I want to see stuff that completed. How do we do that? What's that? State is finished. What else should I filter on? I guess a specific data set. So data sets. I feel like I'm not seeing some of these options. Okay, data set is, let's do IM lines. And then, yeah, let's call that good. So, yeah, we can see who got the lowest loss. It's still Generous Smoke 878, which is probably, oh no, it's Tom from FSDL. I thought it would be Chris. But ran for 2 hours. So that's actually pretty fast. And it got a loss of 11.8, which is the lowest one. So we could look at the resource usage. So yeah, the GPU was getting used pretty close to 100%. That's pretty good. Only one GPU used. We can look at the model. So we got LSTM. Looks like there's 2 layers of LSTM. Is Tom here? Yeah, what did you change the architecture?
Yeah, I changed it.
Nice. So what's a good way for people to see what you did? Is there like a way to get your code?
Yeah, there's a diff.hatch in there that you can apply. But unfortunately, it includes diffs from all the labs, so it's kind of noisy.
Oh, I see.
But you can apply that in the lab.
Yeah. So we could check out basically this exact thing that he ran and then take a look at the model. But it looks like there's multiple layers of LSTMs, other changes. And the result is that it got to super low loss in just 2 hours, whereas I think the model that we started with probably gets here after like 12 hours or so. This will be open for the month after the labs. So please, change things as you see fit and see how things go. OK, so I wanted to open up the README of Lab 7 and increase the font size even more. So yeah, we want to add linting to the code base. And the linting script is called lint.sh. It's in tasks. It is helpful to have slides here, but you can open that file up on your computer too to follow along. But this script is going to be run every single time someone pushes code to our repo. And we're not going to merge their pull request unless they pass all of our tests. So what are the linting tests that we're going to do? The first one is pip check. So this one scans the exact requirement versions that pipfile.lock specifies for known security vulnerabilities. So every now and then something comes out and says, TensorFlow version 1.11.3 is not robust to this adversarial image attack. And so please upgrade to at least version 1.12. pipemp check will report that. PyLint is a static analysis of Python module, both style and bugs, potential bugs. PyCode style checks Python files for simple style violations like line length and stuff like that. PyDoc style I've commented out because, I don't know, but you should uncomment it. MyPy is a static type checker, so that's very helpful for catching when you call a function with parameters that aren't quite right for it. Bandit is static analysis for common security vulnerabilities. Shell check is an awesome one that scans your shell script, like this one, lint.sh is a shell script for potential bugs. There's a bunch of potential bugs in shell scripts, but shell scripts are still very useful. It's kind of like the lingua franca of Unix, ties a bunch of scripts together. And then lastly, if we fail any one of them, we will still run the other ones, but we'll also report that we failed the overall linting. So a little config is needed to make people happy on your team. You should discuss it. The things in the lab is pretty good defaults, I think. But you can specify, when should PyCode style yell at you for exceeding line lengths. For me, it's 120 characters. For some people, it might be 80 characters. What is your documentation string convention? Mine is NumPy. MyPy, should you ignore missing imports, and so on. So the next thing I want to talk about is CircleCI config. And so here, so I have to open this in the browser because it's kind of hard to open dot files in the environment. But yeah, remember when I was talking about CircleCI, I said everything runs in a Docker container, but you specify the commands that run. So we're going to use the CircleCI Python 3.6 Docker container or Docker image that they provide. It has like the stuff that talks to CircleCI, and it has the stuff that Python requires. So that's a good starting point for us. And then you go through the steps. This is the continuous integration pipeline steps. So the first thing we do is we check out the repository of our code. It's this simple command checkout. The second thing we do is we restore, well, let's actually ignore that for now. We install git LFS because it's not part of this Docker image. If we wanted to avoid this command, what we could do actually is make our own Docker file that basically runs this, save that Docker image, push it to Docker Hub, and then in here, we could, instead of the CircleCI, we could say fsdl ci image. And then it wouldn't install git LFS. So that's exercise to the reader if you want. We install shell check. That could be done in our own Docker image also. We install the dependencies. So this should be done here in CI, not in the Docker, because this is going to change. Like every time I push a different version of pipfile.lock, I want this to run because I want that exact set of dependencies to be used in my testing. The next thing I do is I run linting, and I always do that. It doesn't matter if I failed above. I'll still run the linting, and it just runs this lint.sh command. The next thing I do is I run the prediction test. I also do that always, so even if the linting fails, I still want to run the test. The reason for that is because it's just kind of annoying. Like sometimes you have a linter violation, and it's annoying to not run the test because of that, because you'll find that it didn't run anything like an hour later. You fix the linter, and then you finally see the test run. It's better to just like see both outputs. And then this runs the test command, which is really pytest, all the test and text recognizer. Those are the prediction tests, so that's what we call functionality tests. So those are like the quick running ones. Additionally, we're going to run the evaluation tests. So those are the ones that might take a little bit longer. I think for us, they would take like 5 minutes or so. But they can grow up to be like maybe even an hour. And this is going to run our model on the whole validation set. Lastly, we're going to, if there's any test reports, like for example, you can do test coverage analysis, and you can store that artifact here, and then in CircleCI you could see it. So how does that actually work? So in CircleCI, I guess I can log into it. So I have my full stack deep learning organization, the full stack deep learning text recognizer project, and I have a history of all the pushes I ever did. This last one, we can look through it, and sure enough, it just goes through those steps that we were looking at. So it pulls LFS files, installs shell check, runs linting, run predictions test. So here's run linting. It logs the output, quite nice. Run prediction tests. If a test has failed, then here I can look in the log. I can see which one's failed and try to fix it up. And that's basically it. So if you want to try it out for yourself, the way to, oh yeah, and then the last thing that we get out of that is in our GitHub, the full stack deep learning text recognizer project. Let's say there is a pull request. I guess this one. So Chris made a pull request to the repository, and it reported that it ran all the tests, they passed, so we were able to merge it. If you want to do it for yourself, there's instructions in the README. And it's basically, you're going to have to fork the FSDL text recognizer project repo into your own user account, and then go to CircleCI, start the project, link it to that GitHub repo, click Start Building, and now you can build your own, you can run it on your own pull requests. So quite easy. A lifesaver and a way to work with a team productively because you're not constantly arguing about code style rules.